this video, we're going to talk about something called the greatest, oops, well, I messed that up. Let's try that again. The greatest, that didn't work again. The greatest common factors. Sorry about that. Greatest common factors, also referred to as GCF, and those are just the letters that represent each one of the words. So we're going to talk about some vocabulary and then we're going to get started. I will warn you that you will not be able to do this lesson if you have not yet mastered prime factorization. So please make sure that you go and do that first before you move on to this lesson. So what is the greatest common factor? The greatest common factor is the biggest number that factors evenly into two or more larger numbers. And so what I want to do is just give you an example of a couple different ways to find the greatest common factor. So if I have the number, let's say the number 20, and I also have the number 30, okay? What you can do to find the greatest common factor is you can sit here and list out the factors. So you can do 1 and 20 and 2 and 10 and 4 and 5, okay? Now I'm going to do the number 30. So I have 1 and 30, 2 and 15, 3 and 10, and 6 and 5. And so all greatest common factor is asking you to do is to take all of these numbers that go in here evenly and find the biggest match, okay? So the biggest match in this case is going to be the number 10. Now, sometimes it's going to be easier to solve it this way. And the reason why is because these are not really big numbers and most of you can determine the factors offhand. However, when I start giving you numbers that are in the hundreds, that are a little bit more difficult to break down, then there is another way to do it with factor trees that is a lot easier. But keep in mind, if you ever get stuck, you can go back and list out the factors that way. So I want to show you how to do it with factor trees. So what you're going to do is you're going to make yourself a little chart here. I'm asking you to find the GCF between 28 and 42. And again, I can sit there and list out all the factors and find, again, the biggest one, the greatest common factor between the two of them. But here's another way. Let's make a factor tree for 28. We have 2 and 14, and again, if you break them up differently, that's fine. I'm going to do 2 and 7, okay? Now I'm going to do 42, so I have 2 and 21, and I have 3 and 7. And remember, even if you broke them down differently, it's okay because you're going to end up with the same number circled at the end. Now, here's how you find the GCF. You need to find matches between the prime numbers, so between the ones that are circled. So here's a 2 and here's a 2. That's a match, so I'm going to bring over 1, 2. Here's a 2, there's no other 2. Here's a 7, here's a 7. I have a match, so I'm going to bring 1 over. I have a 3 over here, but no extra 3 over here. I have a 2 over here, but no extra 2 over here, so I'm done. Now, I just multiply those two numbers. 2 times 7 is 14, which means that the greatest common factor between these two numbers is 14. This is a significantly easier way. I know it looks like it takes a while, but once you do a couple of them, it's going to go very, very quickly. This is the method I would recommend, but I'm fine if you want to list out the factors as well. Okay, let's do the GCF of 14 and 72. So let's make our factor tree of 14. So I have 2 and 7. All right, let's do our factor tree of 72. I have 2 and 36. I have 2 and 18. I have 2 and 9. And then I have 3 and 3. And so it looks like the only number that I have in common is a 2. And so I'm going to cross out 1 here, and bring it over here. And because I don't have any other numbers in common, the GCF is 2. Now think about if you sat there and listed out all the factors of 14, which is actually not a lot, but then all the factors of 72, and it turns out that the biggest number they had in common was the number 2. It could get frustrating, okay? Let's take a look at another example. the GCF of 15 and of 45. So let's make a factor tree for 15. So I'm going to do 3 and 5. And then a factor tree for 45. I'm going to do 3 and 15. And then 3 and 5. Okay, so where are my matches? Well, I have a 3 here and a 3 here, so I'm going to bring one over. The key to this is you're only bringing one over, not both of them. I have a 5 here and a 5 here, so I'm going to bring one over. I don't have any left here, so it's impossible to match. So 3 times 5 is 15, and the greatest common factor, the biggest number that goes into those two numbers evenly, is 15. Okay, let's do the greatest common factor of 30 and 42. So I'm going to make a factor tree here for 30. So I'm going to do 2 and 15. I'm going to do 3 and 5. And then I'm going to do 42 over here. So I'm going to do 2 and 21. And then I can break up 21 into 3 and 7. Okay? So let me find my matches. So I have a 2 here and here. So I'm going to bring one over. I have a 3 here and a 3 here. So I'm going to bring one over. I have a 5 here, but no 5 over here. And I have a 7 here, but no 7 over here. So I'm going to multiply 2 times 3, and that is going to give me a GCF of 6. So the biggest number that goes into both of those numbers evenly is 6. All right, now I'm going to give you an example with 3 numbers. The process is the same. The only thing that's different is that instead of finding a match in 2 columns, I need a match in all 3. So let me show you how that'll work. So let's do a factor tree for 16. So I have 2 and 8, and then I'm going to break 8 down into 2 and 4, and I'm going to break 4 down into 2 and 2. All right, over here I have 48, so I'm going to do 2 and 24. I'm going to do 2 and 12. I'm going to do 2 and 6. And then I'm going to do 2 and 3. Okay, now I'm going to do 72. So I have 2 and 36. I have 2 and 18. I have 2 and 9. And I have 3 and 3. Okay, and look how much quicker those go as you get used to doing factor trees. So now I need to find a match in every single row. So I see 2's. So 2, 2, and 2. But I'm only going to bring it over once. All right, I see 2's again. 2, 2, and 2. But I'm only going to bring it over once. Then I have a 2, a 2, and a 2. But I'm only going to bring it over once. Now I have a 2, but nothing left over here in terms of 2's. I have a 3 here and a 3 here, but no 3's over here. So that's not going to work. So I'm done. So 2 times 2 is 4. 4 times 2 is 8. And the biggest factor that goes into both of those is 8. All right, you go ahead and try this example. And I will show you the answer here. I think you might have to do it on another sheet of paper because there's no room on your notes. So you can pause the video if you need more time. All right, go ahead and unpause the video, or sorry, pause the video if you're not done and you need more time. So here you should have been able to bring over a 3 and a 5 so that you get a 15. If you did not get that, go back and make sure you did your factor tree correctly. Look at mine if you want to copy mine. But again, I'm not going to go too in depth into how I separated mine because, like I said in the beginning, you can always, your factor tree may look different, but your prime numbers should all be the same as mine. All right, go ahead and try this example here. GCF of 48 and 84. All right, go ahead and pause the video if you need more time. So here we have the greatest common factor that you should have gotten is 12. You should have been able to bring over a 2, another 2, and a 3. And again, if you did not get those numbers, go back and make sure that we have the same prime factors circled. Again, it does not matter how you set your tree up as long as you have the same numbers circled. All right, go ahead and try this one with 3 numbers, keeping in mind that you need to have a match in every single column in order to bring it over to the multiply column. All right, pause the video if you're not done and you need more time to work it out. So here you should have been able to bring over 3 2s, but nothing else. You should be left with a 5 in the 40 column, a 3 in the 24 column, and a 2 in the 16 column. Keep in mind you have to have matches in every single column in order to bring it over. All right, that is the end of the GCF lesson. Please make sure that you are checking every column before you bring a number over, and ask me any questions you have in class.